A Carnot engine is to produce 400 joule of work per cycle. If 600 joule of heat is exhausted to a 27 degrees C cold reservoir per cycle, what is the change in entropy of the hot reservoir per cycle? The substance in the Carnot engine will perform a cyclic process. In every cycle, the work produced is given as 400 joule. So the output work is equal to 400 joule. In every cycle, the heat wasted to the low temperature reservoir or the cold reservoir is 600 joule for every cycle. So this one we denote it, this value we denote it as the QC. So QC equal to 600 joule. The temperature of the cold reservoir is 27 degrees C. In Kelvin, it is 300.15 Kelvin. So Tc equal to 300.15 Kelvin. Now we want to find the change in entropy of the hot reservoir in every cycle. The hot reservoir will provide the heat to the substance in the engine. So the quantity of heat released by the hot reservoir is denoted as the QH. The entropy change of the hot reservoir delta S will be equal to the QH divided by the temperature of the hot reservoir. The subscript H refer to the the temperature of the hot reservoir. Now we start to calculate the entropy change for the hot reservoir, which is equal to the QH over TH. We know that the efficiencies of the heat engine is eta equal to 1 minus QC over QH. This formula for the thermal efficiencies of the heat engine is applicable to all types of the heat engine, including the Carnot engine. But we know that the Carnot engine, its efficiencies, also we have another specific formula for it, which is eta Carnot equal to 1 minus Tc over Th. Please bear in mind that this first formula is applicable to all types of the heat engine, including the Carnot engine. And this one is a specific form for the thermal efficiency for Carnot engine only. It is not valid for other types of the engine. That means these two values of the thermal efficiency in these two formulas should be the same for Carnot engine. Therefore, QC over QH must be the same as the TC over TH to get these two values of the eta the same. And we can get now the QH over TH is equal to QC over TC. But QH over TH is the entropy change of the hot reservoir. And since the terms at the right hand side, they have the same form as the terms at the left hand side, that means we can know that this one at the right hand side is the entropy change of the cold reservoir. So the entropy change for the cold reservoir and the entropy change of the hot reservoir for the Carnot engines, in terms of magnitude, they are the same. So now we can evaluate the entropy change of the hot reservoir for a Carnot engine through the entropy change of the cold reservoir for the Carnot engine. The QC and the TC values are given in the questions. For QC, it is 600 joule, and for TC, it is 27 degrees C. In Kelvin, it is 300.15 Kelvin. And then now we can get the answer is 2.0 joule per Kelvin. This is the entropy change for the cold reservoir and also the same as entropy change for the hot reservoir. In magnitude, they are the same. But for the hot reservoir, the change of the entropy is equal to QH over TH, where the QH is the heat released by the hot reservoir. Therefore, the delta S, the entropy change for the hot reservoir, we should take the 2.0 joule per Kelvin, and in front of it we should put a negative sign. Because the heat is flow from the hot reservoir into the substance of the Carnot engines, so the entropy in the hot reservoir is reducing. That is why we need to put a negative sign. But for the cold reservoir, the magnitude is a 2.0 joule per Kelvin for its entropy change. But since the QC is a heat flow into the cold reservoir from the substance of the heat engine, then of course the QC is a positive value. Therefore, the entropy change for the cold reservoir is a positive 2.0 joule per Kelvin. Okay, for the hot reservoir, it is negative 2.0 joule per Kelvin. So please bear in mind that we are not calculating the entropy change for the substance in the Carnot engine. We are calculating the entropy change for the hot reservoir and the cold reservoir. And for hot reservoir in these questions, the hot reservoir, the entropy change, the answer is negative 2.0 joule per Kelvin.